Oh, wow, it's been a long time. You guys took forever with velocity and acceleration. That's all right. We're good. We'll keep moving. What this one's going to be about is going to be about more rules and more trig rules. But you guys got trig, and it's like, oh, gosh, you're going to get scared again. Trig. You hate trig, but it's okay. Don't worry. One problem at a time, right? So here are your rules, okay? If you want to take the derivative of sine, the answer is cosine. If you want to take the derivative of cosine, it's negative sine. Those are the rules. You might want to like highlight them and say, this is important, okay? Because we will be using this, put exclamation points, little hearts saying, I love this, right? Stars, whatever you want. Okay, these are important, okay? Here we go. So here I'm going to find my first one. I'm going to find derivative of x squared times sine x. Notice I didn't give you anything easy. So what am I doing here, okay? So you think self. What do I need? What type of derivative is this? What type is this? I'm multiplying two functions together. Multiplying two functions. I bet you I'm going to use a product rule. Okay, so I'm going to use a product rule. Again, remember product rule says leave the first one alone. So my derivative, I'm going to just call it y prime, is going to leave the first one alone. Take the derivative of the second. The derivative of sine we just found out was cosine of x. Okay, plus, okay, leave the first one alone, sine of x, times the derivative of the second one, 2x. And then I'll just go ahead and rearrange this to make this nice and easy. X squared cosine x plus 2x sine x. And there we are. We're done. There's our answer. Boom. Okay, nothing too difficult. Next. All right, so in this example, you're going, oh no. It's a quotient rule. Okay, it's all right. You just got to remember what your quotient rule is, right? Your quotient rule is going to be what? Yeah, it's that low d high minus high d low all over low squared. Don't forget that's y prime, right? So now let's go ahead and do this. All right, step at a time. So y prime is equal to low 1 minus sine x. Okay, derivative of high times the derivative of high. Derivative of high is sine of x, negative sine of x. Okay, minus high d low. Well, high is going to be cosine of x times the derivative of low. Derivative of low, well, derivative of 1 is 0. Derivative of a negative sign will be a negative cosine of x. All over low squared, so 1 minus sine of x squared. Wow, that's a lot. I know. So let's go ahead and clean this up a little bit, right? So what I got here first, I have y prime is equal to 1 negative sine x times 1. So it'd be negative sine x minus, well, in this case, negative sine x times the negative sine x. Oh, that's going to be a positive sine squared x. All right, so then I have here minus, and this is going to be a negative cosine squared x. So minus a negative cosine is the same thing as plus a cosine squared x all over a 1 minus a sine x squared. And this is where you got to go self. Can I simplify any more? And the correct answer is yes, because do you remember this right here? Sine squared plus cosine squared is 1. So when I go ahead and do this and simplify a little bit more, is negative sine of x plus a 1 is all over 1 minus a sine x squared. And now this is where you got to do a little bit of imagining, right? Because it's addition, I can flip this. So 1 minus sine x. Hey, look, I got 1 minus sine x squared. Okay. I can go ahead and, to make this simple, I can go ahead and say this is 1 minus sine, oops, need an x over 1 minus sine x squared. So now I can cancel out this whole thing with this 2, and I'm left with 1 over 1 minus sine x. Whew, all that work. And it's not that bad looking, right? So it's all right. We'll go on. We'll do what's next. Next. Okay. The motion of a weight on a spring. Boom. So I want to say here, so the weight hanging from a swing, okay, is stretched 5 units beyond its rest position and released at time equals 0 to bob up and down its position at any later time is 5 cosine t. What are the velocity and acceleration at time t? So again, we have to bring this back. We have to say, well, here I have my position is equal to 5 cosine t. I want to find velocity, which is equal to s prime of t, which is equal to, well, again, constant, so I'll leave the constant alone. And I find what's the derivative of cosine? Derivative of cosine is negative sine t. And when I go ahead and multiply that back out, I now have negative 5 sine t. My acceleration is similar in the sense that acceleration is equal to v prime of t. I take the derivative of it. Again, negative 5 stays. Derivative of sine is just cosine. And there we go. So we found our velocity, we found our acceleration, but now it tells me that I want to describe the motion. Okay, I want to describe its motion. All right, well, let's do that. So the best way we can do this is we can go ahead and graph our two functions that we have. Now you may be rusty on graphing sine and cosine functions, okay, but work with me. So I'm going to graph my position function over time. It's cosine. The 5 means my amplitude is going to be increased to 5, so this up here is 5. Cosine starts up here, travels down, comes back up. Let's try that again, make it look better. There we go. This down here, even though it may not look like it, is negative 5. And you got to remember all your points of interest here. Okay, it's going to cross here at 0 at pi over 2. It's going to cross over here at this other 0 at 3 pi over 2. And this is going to be pi. So what describe its motion? So this is my position function. So again, it starts off at 5, goes down, bottoms out at negative 5, okay, and then comes back up to positive 5. So what's happening is my spring is being stretched 5 units beyond its rest position all the way to the top, okay, and then I drop it, and it drops down, and then bottoms out and comes back up. So it drops down the same 5 units. This is its rest position right here at 0. Okay, drops below the rest position, comes back up. That's the describing its position. So you could say that it falls from 0 to pi, and then it goes back up from pi to 2 pi for my time. You can also describe it as it starts off 5 units above its rest position, decreases to negative 5 units below its rest position, and then comes back up. All right, that's describing from position point of view. But what about from a velocity point of view? From a velocity point of view, v of t, here's my graph, and then this is going to be negative 5 sine t. So again, negative 5 sine, I start here, and I go down to negative 5, and I come back up, and I go down. So this right here is pi, and this right here is 2 pi. And again, you're going to be asking yourself, does this make sense? Does it make sense that my velocity is negative until pi? Well, let's go back to my position graph. My position graph, look, it was falling for the first up until pi. So does it make sense that this is negative? It should, because negative again means it's falling. Negative velocity means it's falling. Right here at pi over 2, not pi over 2, yeah, pi over 2. Okay, does it make sense there that I'm falling at my best speed, highest speed? Yes, it does. I am falling at my highest speed at pi over 2 because it's right in between there. So as I'm falling down, it's going to be my fastest speed before the tension of the spring starts taking over. Okay, and I start slowing down, and then I start speeding up. Okay, So that's what it means to describe your position. You're going to have to put things into words. Okay, use time intervals, but this is what you need to start thinking in your head. All right? More rules. Lots of rules. Okay? These again. All right. Important. Got to know. Okay. Heart. All right. Yes, you need to know all of them. You need to know what the derivative, tangent, derivative, cotangent, secant, cosecant. Here's what I'm going to show you, a nice little trick. If it's tangent, okay, if it's the tangent one or a secant one, the non-co ones, I'm always positive. Okay. If it's the cotangents or the cosecants or the cosines, my derivative is always negative. Okay. The rest of it you just got to kind of memorize. Okay. So hearts, stars, take it like that. And one more example. Here we go. It says a trigonomic second derivative. I want to find y double prime if y is equal to secant x. So just directly from what I was just showing for my rules, so y prime is equal to secant tangent x, tangent x. And now I want to find y double prime. Y double prime. Again, you have to be thinking yourself, what am I dealing with? I have a function times another function. So that means my product rule. So what does product rule mean? Product rule means that this is going to be, leave the first one alone, secant x, times the derivative of tangent x, which is going to be secant squared x. Again, straight from your rules that you just did, plus, and then I go ahead and leave this one alone, tangent x, times the derivative of the first, which is secant x, which is going to be, again, secant x, tangent x. And I can do some simplifying of secant cubed x plus tangent squared x, secant x. And there it is. You're done. There's your first two derivatives. And that's it. There's your homework. Good luck. God bless. All right. Enjoy. We'll see you guys tomorrow.